6.3, I've got it titled as Modeling Revisited in Some Equations. It was a hard one to title because there's a little bit of problem solving in there also. We're going to start out looking at modeling again and revisit the idea of creating a model and then adding one little thing to it, which is if we make two different models, how do those compare to each other? Here's the situation. Jackie has two choices on how she can be paid at work. She can receive $50 for every computer she sells, or she can receive $250 a week plus $25 for every computer she sells. We're going to create a model for each method of pay. I want you to take a second and try to create a model for the first method where she gets $50 for every computer she sells, and then a second model, which is $250 per week plus $25 for every computer she sells. And so we'd be looking at her weekly pay here. Take a second, try to come up with a model for each of those, then I'll do it. You can look at yours, look at mine, see if there's anything you want to ask about how we came up with those models. Pretty similar to our pizza example from Tuesday, honestly. So the first one here, she's going to get paid $50 for every computer she sells. So you could use different variables for this, but I'm going to say her pay is equal to $50 for every computer. So that's 50 times C. Her pay is going to be $50 for every computer, 50 times C. That's model number one. Model number two, then, will be, let's see, her pay is going to be $250 no matter what, plus $25 for every computer she sells. And so there's our two models. A model where she gets paid strictly on commission. Whatever you sell, that's what you get. Or a model where she gets a little bit of pay plus a little bit of commission. If there are any questions on those, let me know. Coming up next, I'm going to have you try to help Jackie choose. With method should she choose? So the two models we came up with was that her pay was 50 times the number of computers, or her pay is 250 plus 25 times the number of computers she sells. And it's just sort of a blanket question there. Which method of pay should Jackie choose? And I'll let anybody tell me who wants to tell me which method of pay Jackie should choose. She gets to pick. Does she choose option A over here, that's all commission? Or does she choose option B over here, that is salary plus commission? Let me know what you think. If you're thinking kind of depends on how good Jackie is at selling, yeah, I would agree with you on that. But there's some things we want to take into consideration, and then there's some things we can do to help Jackie decide. Maybe she came to us for advice, and we're going to point her in the right direction. I guess it could be a him. I don't know. Okay, there's one approach that Leslie says, hey, if I take option B, I am guaranteed to get at least 250. Nicole says B. Stephanie, B is pretty universal here. Okay. Now, the base pay, there again. Is there something we could do where we could say, well, Jackie, let's look back at your average number of computers that you sell, and then that will help us. There you go. I like Courtney's answer very much. That depends on how many she's selling. Absolutely, it does. So let's do this. Let's think, what number of computers sold would make this pay equal? And the way that we'll figure that out is we'll look at the two and we'll say, well, when would 50 times C be equal to 250 plus 25C? If we look at those two things, let's decide what number of computers is going to make this equal. When would 50C equal 250 plus 25C? And what we're doing here in setting up this equation is figuring out how many computers does Jackie have to sell for the pay to be the same either way. That'll be sort of our starting point. Well, let's see, we need to solve this equation. So I'm trying to get C by itself, but here, I don't know if we saw one like this before. We have a C on the left side of equals and a C on the right side of equals. When that happens, when we have a variable on both sides, and the algebra skills that most of y'all have is really good. So bear with me if this feels elementary. I'd rather review it for everybody just to be safe. But we have C on both sides of the equation. When this happens, we want to have C on one side of the equation. So I'm going to subtract 25C from the right so that the C goes away on the right-hand side, and now I'll only have C on the left. If I subtract 25C on the right, I have to subtract 25C on the left. And when I do that, that leaves me with 50C minus 25C is 25C is equal to 250. One more step to go to get C by itself. I'm going to have to get rid of multiplication on the left-hand side. So I'm going to divide by 25. Those will cancel, leaving just the C. If I divide by 25 on the left, I have to divide by 25 on the right. And when I do that, I find out that C is 10. It's important to know what this 10 means. What that 10 means is, if Jackie sells 10 computers, then she makes the same amount of money either way. If she sells 10 computers, she makes the same amount of money either way. So with that in mind, if we look back over Jackie's history and we see that she normally sells 17 or 18 computers every week, with that in mind, we would probably lead her towards choice A. If instead she only sells 2 or 3 computers every week, then we would lead her to choose option B. So which one should she choose? Well, that kind of depends on how many computers she's going to sell. If she's going to sell more than 10 computers, we would choose option A. If she's going to sell less than 10 computers, then we would choose option B. If she's going to sell exactly 10, then it doesn't really matter. You could choose either one. But so this is sort of an open-ended question. Which method? Well, it depends. How many computers is Jackie going to sell? It's kind of what Courtney was getting at. A little bit of an algebra review there, and I've said it before, we won't do a ton of algebra in this class, but we will do some. So every once in a while, we'll revisit algebra a little bit. Something we haven't done yet is graphing. Again, we're not going to do a ton of graphing in the class, but I at least want you to just kind of see how a graph could be used to take a look at this comparison. We had 2 different models. We had one model where her pay was equal to 50 times C. I'm going to rewrite that a little different. Somebody might have mentioned this last week as y equals mx plus b. I'm going to rewrite this as y equals 50 times x, just because what we've got here is an x-axis along the bottom and a y-axis here going vertically. So we have our x and y axis, so I'll rewrite it using x and y as the variables. And then we had another model that was the other method of payment, which was that the pay was going to be 250 plus 25C. And if we rewrite that using x's and y's, we could say y equals 250 plus 25x, where x is the number of computers that Jackie sells. And we have those 2 different equations, and we looked at how to compare those as equations right here. I can set them equal to each other and solve to figure out the break-even point. And once I know the break-even point, I can figure out which pay scale to use. Now, graphing these, you may not remember graphing lines, and that's okay. You're not going to be asked to graph a line out of nowhere. I just want to make sure you can read a graph if you're given one. But I am going to go ahead and do a little graphing here. Y equals 50x. There's a couple of ways you can go about graphing a line. One way, if you happen to remember y equals mx plus b, is you could see here that the slope is 50 and the y-intercept is 0. And you can use those to draw the graph. If you remember that, that's fantastic. If not, that's okay. Y equals 50x. Another way that we could graph a line is just by using points. If I pick something for x, say 0, and I plug it in, 50 times 0 gives me 0. And then, okay, well, what if she sells one computer? Okay, well, 50 times 1, that would be $50 of income. And what if she sells two computers? 50 times 2 would be 100. And then once we have some points, we can kind of plot those points. Remember, x is the horizontal axis and y is the vertical axis. So we'll plot these. I have 0, 0. I have selling one computer is $50. Selling two computers is $100. And you can kind of see how this is going to go. Then let's see here. 4 computers would be 200. 6 computers would be 300. 8 computers would be 400. And then essentially what we've got is a line that shows how much she's going to make. We could do the same thing with the red one. Oh, hang on a second. If you were using y equals mx plus b and you were thinking, well, wait a minute, if I know the y-intercept is 0, then I would have a point at 0, and then 50 over 1 is the slope. So I go up 50 over 1, 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 and then I can draw my line, and that works too, depending on how much you remember about graphing lines. Just right now, all we've done is graph option A to see how much money she would make. Kind of question you might be asked would be just given the graph. So, not given any of this, just given the graph, a question might say, here's a graph showing how much money Jackie makes based on the number of computers she sells. If she sells 8 computers, how much money does she make? And I want to make sure you're comfortable reading the graph, finding 8 computers, going up here, and then saying, well, if she sold 8 computers, she'd make $400. Most of you are probably comfortable with that, but in case you're not, or if you have questions about it, it's fine to ask. You may not have looked at a graph in a really long time. And so that's why we're doing kind of a elementary review of graphing. And like I said, you're not going to be asked to graph y equals mx plus b type things. That's not what our class is about. It's really more about being able to read a graph and interpret it correctly. Let's look at the red one down there. Same thing, we can make an XY table for that. And in this case, if Jackie sold no computers, if X was 0, how much money would she make? $250. Perfect. So we would have a point, X is 0, Y is 250. And going from there, if she sold one computer, we'd add $25. That'd be $275. Kind of hard to graph $275 on this axis, but we can ballpark it. Doesn't have to be perfect. And then 2 computers, that'd be $50 added onto the $250. So now we're at $300. And so we're at 300. And we kind of see how this is going to go. We can plot more points, but really what's happening here is we've got a y-intercept of 250. And I go, because my slope is 25 over 1, I'll go up 25 over 1, 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 up 25 over 1. And I can see how that line is working its way across. And what's going to happen there when I draw that line is this. And then I can look at this picture and I can say, well, here's the option B for salary, and here's option A for salary. And sure enough, what I calculated on the last slide, right here at 10 computers, that's the break-even point. At 10 computers, the money's the same. So if she's going to sell less than 10 computers, I want to do this the red way. if she's going to sell more than 10 computers, I want to do this the blue way. And that's the kind of interpreting from graphs that you'll be expected to do. If it all feels comfortable to you, that's terrific. If you have any questions about it, please don't hesitate to ask. All right, excellent. Some more comparing models. This one I'm going to let you try it. A streaming music plan has two options. A customer can pay $5 a month plus 10 cents per song, or $12 a month for unlimited music. How many songs would they need to listen to in order to make the unlimited choice the better option? So it's a little bit like what we did with Jackie selling computers. We need a model for the $5 a month plus pay as you go plan. We need a model for $12 a month for unlimited. And then the question is, how many songs would someone have to listen to make the unlimited the better choice? I'll set up a poll for this and I'll let you solve it, and then we'll talk about it together. Our question here is how many songs, so we know our answer is going to be a whole number. I suppose you could listen to a fraction of a song, but if you listen to a fraction of it, you'd have to pay for it. So be careful when you set up your model here, well, models, and then decide how many songs would you need to listen to make unlimited the better option. This is another one of those times where it's possible you come up with an answer that's not one of the answers shown. If that happens, that's okay. You just pick the one that's closest to yours, and then when we go through it together, see if there are any questions you want to ask about how we arrived at the answer that we got. But I'll give you some time on this. You're creating two models and then doing a comparison to see what is it that would make unlimited the better option. And it's the same kind of comparison we did when looking at which salary option Jackie would choose. One thing I'll say with today also is that I mentioned that 6.3 is kind of a shorter section, so we can be very patient with the polls. I can give you plenty of time to get a response in. I think we'll go another 20 seconds and then talk about it. Something else I wanted to say is when I say something like, we'll go another 20 seconds, if you're working on it and know you need more time, it's perfectly fine for you just to pop a message that says, I'm not quite done yet. Can you wait? I need a little more time. Something like that to sort of let me know that you're going to need a little longer. That's perfectly fine to ask, and we can just slow down a little bit and make sure you have enough time to answer it. We'll go ahead and take a look at this one and see where we are. Oh, wow, we're spread all over. Okay, so this one definitely doesn't have strong agreement. Let's go take a look at this one, and we'll be real careful and patient as we go through it. Let me know if you have questions as we do this. So there's two different plans. The one where you pay $5 a month plus 10 cents per song. Be a little bit careful here. And you could use different variables, of course, but your cost is $5 plus 10 cents. And I'm going to do 10 cents per song. Be careful. You don't want to use 10 here or else you're paying $10 per song. We're only paying 10 cents per song, so we want to make sure we use 10 cents in that case. And then the other way, the cost would be just straight $12. That's it. So there's our two models. $5 plus 10 cents per song or $12. One of the things I want to mention, we had 4 different answers over there. One of them was just one song. Well, let's think about this for a minute. If this person listened to one song per month, using this method, they would pay $5 plus 10 cents times one song. So that would be $5 plus 10 cents. So that would be $5.10. What we're trying to say is, our question here that we're answering, and we always want to answer the question that's being asked. We look back, pull use 4 steps, look back. So if they listen to one song, we want to know how many songs will they have to make unlimited, the better. Well, if they listen to one song, they're paying $12 for unlimited. They're only paying $5.10 for the pay-as-you-go way. If they're only listening to one song, the pay-as-you-go way is definitely the better option. So taking a look at our answer, putting it back into our two models and seeing, well, one song's definitely not the right choice here. 2 songs, probably not the right choice. That's only going to be $5.20. So what we want to figure out is, when are they going to be even? Just like we did with Jackie selling computers. Where is this cost going to be the same as this cost? That's when the 2 plans are going to be equal to each other. When we think about the graph, that's where they're going to be in the same place. And so we're going to set these equal to each other. We're going to have $5 plus 10 cents per song equals $12. And we just need to solve that for S to figure out how many songs it would take to listen to for the cost to be equal. Please let me know if you have any questions as we go through any of this. All right, so I'm trying to solve this for S, which means I need the term with S by itself, which means I've got to peel this from the outside in and get rid of that 5. To get rid of that 5, we'll subtract 5 on the left. Those will cancel, and subtract 5 on the right. That leaves us with 0.10s is equal to 7. Next step will be to divide both sides by 0.10. Those will cancel, and over here I'll have 7 divided by 0.10. And when I do that, I wind up with S equals 70. It's really important. Oh, let me say it this way. It's really good to be able to set up this model, set up that model, realize that we want to set them equal to each other, and then solve. But then we also want to make sure we understand what it is we just did. What we just did is we found the number of songs that would make the cost equal. If this person listens to 70 songs every month, the cost is going to be the same. What we were asked to do here is figure out the number of songs they would have to listen to make unlimited the better option. So at 70 songs, they're the same. There's no difference. What we want to know is how many songs for unlimited to be better. And so what we need to do is make it so that this way would actually cost more. And so at 70 songs, they're equal. One more song, that 71st song, that's when unlimited is going to be the better option. Because at 71 songs, this way is going to cost more than $12. So 71 songs points us to the unlimited plan. Hopefully that makes sense. Please don't hesitate to let me know if there's something in there that didn't. Hopefully that cleared it up for everybody. All right, I trust you. Let's go forward. It wasn't that long ago that a long distance call came with a cost. It wasn't like it is now where you call anybody you want, doesn't matter. Long distance calling was different not that long ago. And let's say with a certain company, a customer was charged 25 cents for the first minute and then 15 cents for each minute after the first one. Create a model for this situation. So what we're after here is a model for the total cost of the call. I don't think this is easy to come up with, but I want to let you try it. So take a minute, try to come up with a model that would give us the total cost, and we can go ahead and cost equals. So the total cost is going to equal something. How are we going to get that something? What's the model going to look like for this? I don't think it's necessarily easy, but I do think that some of you will be able to come up with this. I'm curious to see what you come up with. So take a couple of minutes, or if you've got it, great, and type it in there. Let's see what you come up with. What we're looking for is if our call is going to be, and I'm sorry, I can't stop talking. If our call is going to be M minutes, what we're looking for, and if you used X, that's totally fine. If our call is M minutes long, we want to be able to plug that in to this model and have the cost of that phone call be spit out. So we want this formula. If I were to plug in the number of minutes, it will give me. All right, that's a great start, Leslie. You are so close. So what we've got there is we're starting out with that 25 cents for the first minute plus 15 cents for every additional minute. It's so close. The only problem with this formula is this is where I paid for the first minute. So if I had a 20-minute phone call and I plugged 20 in here for M, well, I'm paying for the first minute here, but then I'm also paying for it again. I don't want to pay for that first minute again. I only want to pay for it once. So if I had a 20-minute phone call, what would I want to plug in here for M? And if you come up with the formula, that's awesome. But even just the more basic, if it's a 20-minute phone call, what do I want to be plugged in there for M? Not 20, because I don't want to pay for all 20. Oh, you subtracted 15 off of the first one. That's an interesting way to go, Courtney. It's not wrong, but that's not how I want to do this one. Your way is yeah. I'll buy your approach there, Courtney. But yes, Leslie, look at that. If it's a 20-minute call, what I want to plug in here is 19 because I'm paying for the first minute and then I'm paying for 19 more minutes. And so what Leslie said there is exactly right. It's perfect. So instead of plugging in M, the number of minutes for the call, what I want to do is in my formula, I want to use M minus 1. because then if it's a 20-minute call, then I'm going to do 20 minus 1. I'm going to do 19 minutes at this price plus the first minute. And that's going to work no matter how many minutes it was. If it's 30 minutes, I want to use 29. And so this is a little bit of a tough formula to come up with because we don't always think about the fact that algebra is a powerful tool for us and we can put it to work. So here I have m minus 1, however many minutes, take away 1. That's how many need to be charged at the 15-minute rate. With this formula in mind, I'll ask you another question. I won't set up a poll for it, but what would it cost for a 9-minute phone call? And y'all can just type that in there rather than doing a poll for this one. What would it cost for a 9-minute call? We have the formula now, so we're kind of home free. And this one's about making sure you can use that formula properly. It's terrific. It's a nice little review of order of operations. Got $1.45 over there from Courtney and Moylan. All right, let's take a look. So if I want to know how much this phone call would cost, we're going to plug in. The cost would be 25 cents for the first minute plus 15 cents the minutes minus 1. That's where the 9 went. It was a 9-minute call, so we put the 9 in there. And here's how the formula becomes powerful for us is 25 cents for the first minute plus 15 cents times 9 minus 1. Oh yeah, simplifying this thing. Please excuse my dear Aunt Sally. Order of operations. If there's anything in parentheses, we have to do that first. We have stuff inside parentheses, so we better do that first. 9 minus 1 will be 8. Next to exponents, we don't have any exponents. Multiply and divide. We do need to multiply over here. So we're going to multiply next. 0.15 times 8. Let's see. 0.15 times 8 is 1.2. You could do $1.20 if you wanted to. If you're thinking of money, you could do that. That'd be all right. And then we need to add. $1.20 plus 25 cents is $1.45. So this is the type of question that is a little bit of a challenging model, but our job here was to first create a model. We did that, and then answer a question using that model, where here, how much would it be for a 9-minute call? And all we needed to do was plug 9 in for M and then simplify. You just have to be careful with order of operations when you're simplifying. Are there any questions about what we did there to come up with that model or to come up with the cost of a 9-minute call? Okay, very good, very good. Let's look at this one. And rather than a model, this one's really just sort of a problem-solving question. But I am going to set up a poll for you and have you try to solve it. There might be more than one way to go about this. You can certainly set up equations. That's where my brain goes to. Yours might not. You might use trial and error. You might use equations and algebra. Or you might use something else that I haven't thought of. But we want to solve this one. It says Josh and Rachel made a profit of $62 by working at their lemonade stand. So that's how much they brought, they brought in $62. Rachel brought in 40 more than Josh. How much did Josh bring in? I'll set up a poll for this and let you try it. And like I said, there's a lot of different ways you can go here. And questions like the ones that we do in our class sessions, in our polls, are the type of questions you can expect to see in the homework and then potentially on the quizzes and potentially on the exams. So it's a really good time to try them. If you practice them now and you're doing well, then you can feel really comfortable as you go into the the assigned homework problems and the questions you can expect to see on the quiz. If you struggle during our polls or on any of the problems we work on in class, that's sort of an indication that you're not quite ready to start getting everything right, which means you might need a little more practice, and that might do the trick. Or asking for help goes a really long way, and you can do that. When we're going over a question in class is the perfect time to ask questions, but you can also send emails if you want to do that. So I encourage you to ask questions, and I promise you, if you have a question, somebody else does too. You're not alone. So don't hesitate to ask questions if you have them. We'll go another 20 seconds on this and then talk about it. See what we have here. Okay, pretty strong agreement. All right, that's encouraging. Let's take a look at it. Okay, so that most common answer that we got there was 22. So let's see what happens here. I'm just going to start by writing that down. If Rachel, let's see, the question was how much did Josh bring in, right? So if Josh brought in 22 and Rachel brought in 40 more than that, that means Rachel brought in 22 plus 40. Rachel brought in 62. So together they brought in 84. Wait a minute, that's no good. That didn't work. This was a little more complicated than it may have originally appeared. If Josh brought in 22, if Rachel brought in 40, then we're done. But she didn't bring in 40. She brought in 40 more than Josh did. So you got to be careful when you read these. She brought in 40 more than Josh. If he brought in 22, oops, that would mean Rachel brought in 62. And that if he's got 22 and she's got 62, that's not 62 together. So that's no good. We got to blow that one up and throw that out. So let's take a step back for a minute. You could certainly do trial and error here, or another approach you could do is this problem turns out to be a lot like the pigs and chickens problems from last week. Josh and Rachel together, Josh plus Rachel brought in 62. And Rachel brought in 40 more than Josh. So Rachel brought in whatever Josh did plus 40. And at this point, I have two equations and two variables, so we can solve it, and we can use substitution. We can see right in there that Rachel is Josh plus 40, so I can substitute Josh plus 40 in where Rachel goes. And I can rewrite that top equation as Josh plus Rachel, which is Josh plus 40, is 62. And when we solve that, we'll know how much Josh brought in. We can simplify here. J plus J, that's 2J plus 40 is 62. And now we have an equation to solve. We'll subtract 40 from both sides so that those cancel. And now we have 2 times J is 22. And then finally, one more step to go here. We'll divide by 2 on the left to get those to cancel. Divide by 2 on the right. And Josh brought in $11. And that's the answer to our question. Polya tells us, look back, make sure this is okay. All right, well, let's see here. If Josh brought in 11 and Rachel brought in 40 more than that, that means she brought in 51. Her 51 plus his 11, sure enough, That's our 62. You could certainly do this with trial and error. You could say, well, Rachel brought in 40 more than Josh. So what if she brought in 40 and he brought in none? Well, that's not 62, so that's not quite there. Okay, how about 50 and 10? Okay, well, that's not quite 62, but it's close. How about 51 and 11? That'll get it. Trial and error is a way that's not a terrible approach here. If the algebra approach isn't your favorite, trial and error would have been pretty slick for this one. Hopefully, we cleared that up a little bit and made sense of it. If you have any questions, now's a great time to ask those. All right, we got a couple more we're going to look at that are, they might look unusual at first, but I think once you get used to looking at them, you'll see that they're not that different from things that you're already pretty comfortable with. Find the value of the spade and the diamond. So we have a spade and a diamond, and we want to figure out the value of those. And we have two equations and two variables, so we're going to be able to solve this. It's just what approach are we going to take? And I think what happens here right out of the gate is, well, there's a whole lot going on here. I'm not ready for that yet, but you know, up here, this looks like something I can solve. If I have two spades, and I'm not going to be able to draw the spades, so I'm just going to call it an S. If I have two spades is equal to 38, I can divide both sides by 2 and find out that the spade is equal to 19. So I've got that part answered. And now once I know that the spade is 19, I can plug that into the other equation. It's a little bit like what we did with Josh and Rachel just a minute ago. If I know the spade is 19, now I have diamond plus 19 plus diamond is 27. I can simplify that. 2 diamonds plus 19 is 27. And now we just need to finish solving this up. If you have questions about anything I've done so far, let me know. We'll subtract 19 from both sides. Those cancel. And what we end up with at that point then is 2 times diamond is equal to 27 minus 19. That's 8. And divide both sides by 2. We find out that the diamond is 4. We wanted to find the value of the spade and the diamond, and we have those. You can plug them back in to check to make sure. But there's a spade and a diamond. Are there any questions about what we did there before I have you try one that's similar? I think these are fun because they just look so strange. You may or may not agree with me. Okay, find the value of the spade. I'm going to set up a poll for this and have you solve it. One thing I'll tell you, as you're working on this, when I made these in PowerPoint, the diamonds are red like you would expect them to be. Apparently, Big Blue Button said, nope, those diamonds are not going to be red. They're going to be black. So I'm guessing Big Blue Button can only do black and white and maybe gray. And so those red diamonds got turned into black diamonds. So that's not something I did to kind of to try to throw you off. That's just a limitation of Big Blue Button. If you're looking at that thinking, why aren't those red? So was I when the first one popped up there. We don't have to be in a hurry on this one. I'll give you plenty of time. You'll definitely see problems like this in the assigned problems and on the quiz this week as well. So I encourage you to practice it. And let us see how you're, or at least let me see how you're doing as far as the numbers that come in. You know, if I know a lot of people are getting this correct, that tells me something. Kind of like the last one, there were an awful lot of 22s on that, so I wanted to talk about why 22 wasn't the correct answer instead of just talking about the correct answer. So it helps a lot when everybody does the poll. I'll give you a little time. I'm thinking another 30 seconds, then we'll talk about this one together. This one is a little more complicated than the last one, to be fair. Okay, let's see where we are. All right, strong agreement on this one. Very good. All right, let's take a look at it and see what we do with this one. So the last time we were able to just solve right away for one of the symbols. Here we can't do that. But what we can do, very much like what we did with Josh and Rachel, is as I look at the equation on top, what I see there is spade plus diamond is 13. Spade plus diamond is 13. So if I were to peel that off and do spade plus diamond is 13, if I want to get one of those by itself, same way I did with Josh and Rachel, what I can do then is I can say, well, if I subtract D from both sides, those cancel, and I see that spade is 13 minus diamond. And now that I know spade is 13 minus diamond, I can take 13 minus diamond and drop it right in here for that spade. And that's what we'll do. So we're substituting, same thing we did with pigs and chickens, same thing we did with Josh and Rachel. And so now what I've got here is I have diamond plus, instead of spade, I'm going to write 13 minus diamond plus diamond is 21. Now I've got a whole bunch of stuff I need to simplify. Those parentheses, I can't really simplify in there. So we'll just kind of take a look at what we've got. I have, let's see here, I have diamond, negative diamond. Wait, those will cancel each other out. This positive diamond and this negative diamond will cancel each other out. And so what I'm left with here is 13 plus D is 21. We'll subtract 13 from both sides. Those cancel, and I wind up with D is 8. So I know the value of the diamond is 8. Now that's great news, and that's valuable, but this question said, find the value of the spade. So I'm not done yet. And nobody answered 8 in the poll, which is excellent, because that means you may have done exactly what I just did, got to the end and said, but wait a minute, I don't want what the diamond is. I need to know what the spade is. And so we want to make sure we're answering the question that they asked us. And so I'll go back and I'll say, well, there's a couple of different ways you can find out what the value of the spade is. You could either go right back here and just plug in and have spade plus 8 is 13 to get to spade equals 5. Or you could use this over here that you came up with. Spade is 13 minus diamond, so that'll be 13 minus 8, so that's 5. One way or the other, you can get yourself to the fact that the value of the spade is 5. That poll went really well, so that's encouraging. Sometimes these problems with symbols that we're not really used to seeing can throw us a little bit, but it seems like